Year 11, homework 12. We start off talking about the atmosphere. It's mainly about the atmosphere again, this homework. We've got an experiment here, so this experiment will allow us to work out the proportion of oxygen in the atmosphere. Now, if I'm absolutely honest with you, this was specifically talked about on the old specification, the old GCSE specification, the A-star to G specification, and it disappeared on the 9-to-1 GCSE, but I still thought it was something that could possibly come up, so I stuck it in this homework here when I first produced this book. I'm glad I did, because the very first exam on the new specification, this experiment and this diagram was there. So even though it's not on specification, they are still testing it, so it's a good question. A class tried to work out the percentage of oxygen in the atmosphere using this apparatus. We've got copper turnings in the middle here. We're going to heat those copper turnings. We've got two gas syringes either side. This gas syringe here starts with 50 centimetre cubed of gas in it. When I say gas, it's the atmosphere. So oxygen and nitrogen in it. And what we do, we heat this up and then we press this syringe plunge down here and it pushes this atmosphere over the hot copper turnings. And then it comes to this side, to this gas syringe, and this gas syringe will get pushed outwards. And then we can continue pushing these gas syringes. We can continue circulating this atmosphere over this copper turnings. And what we're hoping to do is react the oxygen from this atmosphere with that copper. So hopefully the volume of these syringes will go down. Does that make sense? I hope it makes sense. So after the tubes had cooled down, okay, and that's important because when we heat air, it expands. So we can only take our final measurement at the end when we've turned the heat off. Okay, and the tubes have cooled down, the air's contracted back to where we started with. So we started with 50, we heat it up, it will expand, we circulate the air over the top, the oxygen will react with the copper turnings, we let it cool down, and at the end of the experiment, the volume should hopefully have gone down, because the oxygen from the air will have reacted with the copper, so it will have gone from the syringe, so the volume will have gone down. You can explain that in your own words. Why would the class have to wait until the tubes are cooled? Well, because air, when it heats up, it expands, so we need to wait until it's cooled to the end, so it's contracted, so we can make a like-for-like comparison, because the air was cold at the start, it needs to be cold at the end. Given the air is 20% oxygen, calculate the volume of gas you would expect in the gas syringes at the end of the experiment. Well, if we start with 50, okay, centimetre cubed, what we're saying there is that is 80% nitrogen and 20% oxygen. Yeah? So what we need to work out is the 20% oxygen will have gone into the copper to make copper oxide, so we need to work out what 80% of 50 is. Okay, so what's 80% of 50? Well, if you take 50 and divide it by 100 and then multiply by 80, you should get that answer, but I'll let you do that maths. Okay, you can have a go at that maths. Would the mass of the copper go up, down, or stay the same? Well, we start with copper and we finish with copper oxide, copper joined to oxygen. So first law of chemistry says it has to go up. That's going to be up. And likewise with each of these. Okay, what happens to the mass in each of these experiments? Does it go up, down, or stay the same? Well, if a gas is added to the reactants, it's going to go up. If a gas is lost from the reactants, it's going to go down. And if a gas is not added or lost, the first law of chemistry says the mass has to remain the same. So this one here, a gas is a product, that's got to go down. But you have a look at that one, there's a gas there. Is it a reactant or a product? Does it go up or does it go down? This one here, can't see any gases, so that's probably going to stay the same. So you have a look at each case. Is a gas a reactant or a product? What is responsible for carbon dioxide being added to the atmosphere? Well, we did this in the last homework. Two things responsible for carbon dioxide being added to the atmosphere, two main things, but there are more, I suppose. There's respiration of animals. That's the one. Second one is burning of fossil fuels. You could also say volcanoes, because volcanoes are still with carbon dioxide. But what you don't write here, what you do not write here, is deforestation. Deforestation will be marked wrong. Okay? Deforestation does not add carbon dioxide to the atmosphere directly. Having said that, it will lead to an increase in carbon dioxide in the atmosphere, because a tree, if you cut it down, it can no longer take carbon dioxide out of the atmosphere. Okay, but it doesn't directly add lots of carbon dioxide to the atmosphere. Indirectly it does, but deforestation would not be a great answer to that. Three answers. First one, burning fossil fuels. Second one, respiration. Third one, volcanoes. Okay, there are the 3 acceptable answers. What is responsible for moving carbon dioxide from the atmosphere? We talked about this last time as well. This is dissolving in the oceans or photosynthesis. Right, this graph here, it'll be fascinating to see how many of you get this right, because I think most of you will probably have to watch the video, so it'd be interesting to see how many of you watch the video, really. I first saw this graph questioned, must be around about 1998, I think. Back in 1998, I used to do a SATS extension paper for year 9. I used to have to do a SATS exam in science in year 9. And this graph came up there, and it was I thought it was a great question at the time. So I stored it up, and we use it for our homework now. Basically, in Hawaii, I'll pronounce this very badly, Mauna Loa is on the top of a Hawaiian island in the middle of the Pacific Ocean. So it's a really good place to take atmospheric measurements. They measure the amount of carbon dioxide continuously throughout the year, and the red line is the continuous measurements of carbon dioxide they're taking at that laboratory continuously and have been for the last 50 years. The black line is the trend line as the years go by, if that makes sense. So it's a really lovely graph to look at how carbon dioxide is changing in the atmosphere. Okay, it asks you to fully describe how the amount of carbon dioxide has changed from 1958 to 2013. Okay, the first most obvious thing is we've got an increase. If you just write it as an increase, it's only going to get you 1 mark. You can say loads about this. It's not just an increase though. If you look at it, it's curving upwards, isn't it? So the increase is increasing every year. So there's kind of an exponential increase here. It's not a straight line. You know, if we were to put a straight line on there and draw it, okay, let's put the straight line at the start of that and draw it. Yes, it looks like that, doesn't it? Yeah, goes like this. But it's not. It's curving away from that straight line. So the increase is increasing every year. So every year we get a bit more than the increase we had the previous year. It's an exponential increase. Okay, so we need to talk about that as well. And the third point is every year there's an increase and a decrease, an increase and a decrease. So why are we getting rapid increases and decreases every year? Well, it's twice a year, so it's seasonal. It's seasonal. There's a seasonal difference. So during part of every year we get more carbon dioxide, and then the second half of the year more carbon dioxide is taken out of the atmosphere. So why is that? And if you got that, if you're getting this, if you know the answer, you're doing pretty well. If you look at the globe, if you look at a globe of the Earth, there's more land mass in the Northern Hemisphere. So there's more trees in the Northern Hemisphere. So when it's summer in the Northern Hemisphere, we're taking more carbon dioxide out of the atmosphere, and when it's winter, the leaves fall off the trees, then the carbon dioxide increases. And that is why we have this red seasonal variation. Be interesting to see how many of you write that into your homework. You have to watch the video, I think, to come up with that answer. Right, so there's our trends and there's our reasons, so you can write those in. And that's our last year 11 homework. All the homeworks from now will be past exam papers. You will get 1 past exam paper per homework, and you will be expected to deliver perfection on it. Okay, but that's the end of these homeworks. Thank you.